to add up the parts of the segment. All right. This is actually not that bad, guys. Here's the segment addition postulate. I want you to imagine having a piece of string. And I have my piece of string. Nice dull scissors. Okay. So here's my string, right? And with my string, I can start cutting them into parts. And with all my parts, I keep cutting. Notice that they are different lengths. Okay, so now I have 5 different lengths of my piece of string. Each one's unique, right? Took my entire piece of string and I cut them up into parts, right? What happens if I were to take all these strings and line them up on the desk end to end?
They would equal the same length as they were in the first.
Yeah, okay. So this is a really difficult concept to master. This is why we were able to do all the other stuff today. This is why we're doing notes in about 5 minutes or less. You guys ready? Big idea for today. Essential theme for the course of geometry.
Okay.
Write this down. The sum of the parts equals the whole. I know. Brilliant. Mind-numbing. Like Eureka moment here, okay? Sum of the parts equals the whole.
Yes.
If I add up all the parts of my segment, what do they equal? The whole segment, right? So one of the things I think is really important for geometry students to master is how to write the geometric equation. And not just jump in with numbers and jump in with variables, but write the geometric equation. When we look at this segment, AB, what are the 2 parts of the segment?
AC and CB.
AC and CB, okay? So, therefore, sum of the parts equals the whole. What does sum mean? Add. So therefore, what am I adding?
AC and CB.
And what does that equal?
AB.
Ta-da, we're done.
AB?
That's literally the entire lesson today. AC
I might be
plus CB equals AB. Sum of the parts equals the whole, right? So they AC. There's my AC. There's my BC, and if I add those together, we get the full segment AB. And we're done.
No, how do you show your work for that? Just put AC.
Yeah.
So the first step of your homework needs to be this. Writing out the geometric equation. That should be the first step of your homework. And then from there, we start filling in what is the length of AC, what is the length of BC, what is the length of AB, start filling in those values. So let's look at a couple examples. Here we go. All right, so in this problem, in the diagram we have PT is 20, so the entire length of this segment is 20. QS is 6, and then PQ, QR, and RS are equal. All right, we need to find the length of each segment. Okay? So looking at example 5, what are we solving for? Which segment?
QR.
Gotta solve for QR. Okay. How can I use my segment addition postulate here? What can I add together to get a whole?
Wait, what was the question?
So if I'm solving for QR, what parts can I add together that would help me solve for QR? Danny? Suhei, looks like you're thinking over there. Sure? Okay.
What if
What if what?
well, if it equals all 20, wouldn't they be like all 5?
That's assuming that all of the segments are equal.
Yeah,
The only ones that are
yeah.
equal is PQ, QR, and RS.
Wait, those three are,
Yeah, those three are equal. Right, that's what this means right here.
okay, so you would take, if those three are equal, they each equal 2 because altogether they equal 6.
No. Which one's that if they give you 6?
Okay, so Q and R would be 3 and R and S would
Okay,
be
so QR plus RS is equal to
6.
QS. That's your geometric equation. I want you guys to write that out first.
Equals Q.
Okay. So QR plus RS is equal to QS. All right, now let's plug in the values that we know. What do we know about QR and RS?
They're all the same.
They're
All
equal.
right, so I can substitute one for the other, right?
Right.
So instead, we could rewrite this as 2 times QR is equal to, how long is QS?
6.
So therefore,
QR is
QR equals
Okay, will we repeat that?
3. Since we know that QR and RS are equal, right, that's what we're told up
3.
here, that means that they can be substituted. So basically the same value. So I could rewrite that as QR, or 2 times QR is equal to 6.
We're just gonna get where you got 3.
Okay, so we want to solve for
okay.
QR.
Gotcha. Gotcha.
How do we get QR by itself? Divide by 2. 6 divided by 2 is 3.
Gotcha.
Oh, you should have said that.
All right, so I think this is actually kind of important here. In geometry, these types of things become your variables. The names of the shape become your variables. All right, so it's no longer just x's and y's. So it's important that we recognize that QR is going to be treated as our unknown. Okay, now that we know QR is 3, what does that make PQ?
3.
3. So let's say look at number 6. How do I solve for ST?
Wait, so if those are 3, that adds up to 9, and 20 minus 9 is...
Yes, but how do I set up a geometric equation to do this?
Okay, so
Sum of the parts equals the whole.
we're solving for ST. Okay, so you have PQ plus QS equals ST.
We can do it that way. No, it doesn't equal ST. Plus ST
Plus
is equal
ST
to,
equals PP.
so the sum of my parts equals the whole.
Right.
Okay, now we start plugging in the numbers. PQ is,
3,
QS is,
6,
we have our unknown ST length. How long is PT?
20.
So 9 plus ST is equal to 20, and therefore ST equals 11. How we doing?
Good.
Getting this?
I understand
Confusing. Okay, here we go. Same concept.
Oh,
Okay, find the length of AC. All right, Blake. On number 9, what would be my geometric equation?
AB plus BC equals AC.
All right, so AB plus BC equals AC. All right, and the question is, find the length of AC. All right, so Alexis, what do I start plugging in?
The AB.
Say that again.
AB.
All right, so how long is AB?
3.8.
So 3.8 plus
27.
is equal to AC, and therefore AC is equal to 9.5. number 10. Number 10. Christina, what would be my geometric equation for number 10?
Oh, that's Christina, right?
Yeah.
Go ahead, Christina.
LN MN equals LN.
Yep. Okay. So what are we solving for? ln. All right. All right. So now, Mike, help me out the rest of this.
Alright, plug in 2.8 for MN
Okay.
and LN is 4.
All right. So how do I solve for lm?
4 minus
There we go. Probably should include our units on that. You guys get the point?
So,
Sam?
Will we have any problems that we have to deal with, like conversions, like one
No.
measurement will be like centimeters and the other will be
No.
measurements?
Okay, so we've got this down.
we have fractions again.
Yeah.
Can you go back to that problem and do it with us?
Okay, if you're finding, it's just adding 4 and 5/8 plus 2.5.
Okay, so then,
So you want to improper form again. So 4 times 8 plus 5, 37/8 plus 5 halves for the common denominator.
so times 4, so that'd be 20.
So 57/8.
What was the last number you got?
28.
I thought it was like R.
I wouldn't. I'd leave it like that. No, I'd leave it just like this, 57/8. Alright, this is actually kind of a little more complex, but it kind of gets the point across. Read the directions. Alright, so T is somewhere between S and U. Do we know where it's at in between them?
No.
Does it matter where it's at in between them?
No.
No, in our diagram it really doesn't matter. It's a floating point. Now, just because it's between them, does it mean it's in the middle?
No.
Careful what we assume. In geometry, you can never make assumptions. It's really important that we make sure we get that down. You cannot assume that T is the midpoint. All we know is that T is somewhere in there. That's all we know. And so when we make our diagram, we have S, and we have U, and somewhere in between is T. And when we do this, we can then write the geometric equation and substitute in our expressions. So we know that ST plus TU is equal to SU.
Question.
Yes.
Where did you get LN?
Substitution, that wasn't bad.
So it should be SU.
Should be SU. Okay, so we start plugging these in. ST is 7x plus
5x.
Where's the...
Alright, so then we got 12x minus 3 is equal to 45. 12x is 48, and x is 4. Now here's the problem. Does that solve the problem? Read the directions again. What are you trying to do?
Find the length of x.
So we gotta actually find the lengths of ST, TU, and SU. Well, in order to find out the length of ST, what do I need to solve for?
Plug X in.
Gotta plug x in. X we said was 4. 7x is 28. 5x minus 3. And therefore 45. And we're done. That's our notes.
Maybe we don't do anything else.
Very simple.